Every time you turn on the tap, you trust that the water coming out is safe to drink. But what's actually in your water? It could be chlorine, sediment, heavy metals, or even microplastics. Today, we're going to break down the science of water filtration, how different filters work, what they actually remove, and how you can choose the right system for your home to ensure every glass is as clean and healthy as possible. Let's start with why we even need to filter our water. Municipal water is treated to meet safety standards, but that doesn't mean it's perfect. Depending on where you live and the age of the pipes in your city and your home, your tap water can contain a surprising number of things. First, there's chlorine and chloramine, which are used as disinfectants. They do a great job killing harmful bacteria, but they can leave your water with a chemical taste and smell. Then you have physical particles like rust or sediment that flake off from old pipes. Older plumbing can also be a source of lead, which is a serious health concern. Beyond that, runoff from agriculture can introduce pesticides. And unfortunately, our water sources are also showing traces of microplastics and even pharmaceuticals. Filtration isn't about creating panic. It's about taking control, improving the taste and smell of your water, and reducing your exposure to certain contaminants. So, how does filtration actually work? It's all based on a few core scientific principles. The first is mechanical filtration. This is the simplest form, where water is passed through a physical barrier, like a screen or a mesh. This barrier physically blocks larger particles, like sand, silt, and rust. Think of it like a coffee filter, but for your water. It stops the big stuff from getting through. The second, and probably most common method, is chemical filtration. This usually involves activated carbon. Activated carbon is incredible stuff. It works through a process called adsorption. That's adsorption, where contaminants chemically stick to the porous surface of the carbon. A single gram of activated carbon can have a surface area equivalent to multiple football fields. That massive surface area is why it's so effective at grabbing onto things like chlorine, industrial solvents, and volatile organic compounds, or VOCs, which are often responsible for bad tastes and odors. This is the technology you'll find in most pitcher filters, faucet filters, and the filter in your refrigerator's water dispenser. For more heavy-duty filtration, we move on to membrane systems, with the most well-known being reverse osmosis, or REO. Reverse osmosis works by using high pressure to push water through a semi-permeable membrane. This membrane has microscopic pores that are so tiny, they allow water molecules to pass through, but block almost everything else. We're talking about things like dissolved salts, heavy metals like lead and arsenic, and even things like fluoride and nitrates. The downside is that RO systems do waste some water in the process, and they can strip away beneficial minerals like calcium and magnesium. That's why many modern RO systems include a remineralization stage to add those healthy minerals back in. There are also a couple of other specialized methods worth knowing about. Some advanced systems use ultraviolet, or UV, light. A UV lamp zaps the water, and its light scrambles the DNA of bacteria, viruses, and other microorganisms, making them unable to reproduce and cause illness. Then there are ceramic filters, which are a type of mechanical filter made from porous ceramic material. They physically block microbes and sediment, and they're very common in portable or emergency filtration systems because they're durable and effective. So, with all these options, how do you choose? Let's compare the most common household systems. Pitcher filters are the cheapest and easiest to start with. They're great for basic taste and odor improvement. Faucet-mounted filters are a step up, offering better contaminant reduction right at the tap. Then you have countertop units, which usually have a larger capacity and can offer more advanced filtration. For the most powerful filtration, under-sink systems, often using reverse osmosis, are hidden away and provide a dedicated tap for highly purified water. Finally, whole-house filters treat all the water coming into your home, protecting not just your drinking water, with your appliances and plumbing too. The right choice really depends on your local water quality, your budget, and how much space you have. Now, let's bust a few common myths. Myth number 1. All filters remove everything. The truth is, each type of filter is designed to target specific contaminants. A simple carbon filter won't remove lead, and a basic sediment filter won't do anything about chlorine. Myth 2. Bottled water is always cleaner. The truth is, a lot of bottled water is just filtered tap water, and it comes with a huge environmental cost from all that plastic waste. And myth number 3. Filters last forever. This is a big one. Cartridges have a limited capacity and must be replaced regularly to work effectively. An old clogged filter isn't just ineffective. It can actually become a breeding ground for bacteria. So how do you make an informed decision? Start by getting a copy of your local water quality report from your utility provider. You can also use home test kits to get a snapshot of what is coming out of your specific tap. Consider the age of your plumbing and what your main concerns are. Is it taste, smell, or specific health worries? When you're shopping, look for systems that are certified by organizations like the NSF to remove the specific contaminants you're concerned about. Don't fall for vague marketing claims. Ultimately, water filtration is science, not magic. Once you understand how these systems work, you can make a smarter, more sustainable choice for your home and your health. If you want to check out the filtration systems and test kits that I personally recommend, you can find affiliate links in the description below and in the pinned comment. Thanks for watching. Don't forget to like and subscribe, and I'll see you in the next eco lesson.